All right, welcome everybody. Let's do this. So, lesson number 2, we will be calculating limits from a table. Yeah, and the idea of a table is something like this. So, here, this lesson was not easy for me to make, and let's see how well I do with it. It's much better if I do it live than video, so let's hope for the best. For this lesson, what I'd like you to do is bring your microscope. So the idea is we're gonna look very, very close at a certain number. So like, let's say if I say, let's look at the number 2, we're gonna look very, very close to the left of 2, which is like 1.9, 1.99, 1.999. This is getting closer and closer to 2, notice from the left, yeah? This is getting closer and closer to 2 from the right, okay? So let's take a look at this function. It says, let's see what happens that we get closer to x equals 2 from the left and the right of the following function, f of x equals x squared minus 4 over x minus 2. So based on the previous lesson, if I said, hey everybody, let's take a look at this graph, and we said, okay, as the limit, as x approaches 2 from the left of f of x, what is this going to? Notice that this graph, the closer and closer I get to x equals 2, it looks like the graph is getting closer to 4, right? So notice that the limit from the left is 4, just by looking at this graph. It looks like the limit from the right is also 4, yeah, as you're approaching x equals 2 from the right. So if we know that the limit from the left and the limit from the right is approaching the same location at 4, then the limit in general will equal 4. And let's take a look at the last question over here. It's saying, what is f of 2? And just by looking at this graph, we ask, okay, when you plug in x equals 2, is this an open or closed circle? It looks closed, right? So we're gonna say, okay, it's 4. Okay, so this looks pretty straightforward with a graph. The idea for this lesson is, we want to be able to calculate limits without looking at a graph. So right now, notice that this function of x squared minus 4 over x minus 2 has a graph. This is the graph. Imagine if I said, hey, what are these limits without looking at the graph? How can we find these limits only by looking at it through a table of values? That's the goal for today, okay? But for now, for the first one, it'll be a nice and easy warm-up. What I want you to do is, you see, the reason why it's better live is because I wanted us to do this as a class, but let's do this remote. What I want you to do is go to desmos.com, yeah? And the idea is when you go to desmos.com, I want you to plug in the function of f of x equals x squared minus 4 over x minus 2. And when you type this into Desmos, this right here, Desmos is saving that anytime you plug in f, it has it saved for this. So for example, if I wanted to plug in the number 3.9, if I do f of 3.9, Desmos calculator, well, Desmos for one, will also show you the graph, right? This is a picture of Desmos. So what I want you to do is, you see here, there should be a, f of x equals this function, and it will show you the graph here. So notice that, like, if I put in the function and I put in f of 3.9, it'll plug in 3.9 into the equation, and it will give me a value, okay? So here, if we go to desmos.com, it should look something very similar to this, right? First, you plug this in. So pause the video and take your time, right? First, plug this in. Now, what do we want to do? We want to plug in 1.9 for x. Remember, the idea of what we're trying to do is we're trying to see what happens as we get closer to x equals 2 from the left. So if this is, notice that this is the x-axis over here. As we get closer and closer to 2 over here, what is the y value? Visually, it looks like it's 4. So let's see if the calculations actually match that it's getting closer and closer to 4. So what I'm going to do is, what I'd like you to do is, first plug in these numbers. Plug in 1.9, 1.99, 1.999. You see you're getting closer and closer to 2 from the left. Let's see what the y values are. Notice that when you plug in 1.9, you should get 3.9, okay? If you put in 1.99, you get 3.99. 1.999, you get 3.999, and so on and so on. So it looks like the closer and closer you are getting to x equals 2 from the left, it's getting closer and closer to 4 as you round up. So here we could just type in 3.9, 3.99, 3.999. And here, if I saw these values and I didn't have the graph, I already know that this limit from the left has to be 4 without looking at the graph. Let's take a look at the next part here as you plug it in, right? Hopefully there's no technical difficulties with your Desmos and we're all on the same page, right? That's why it's better to do it in class. But don't do this one yet. Don't plug in f of 2, not yet. So now we're going to get closer and closer to 2, but this time we're going to come in from the right. So first let's start at 2.1 and then work our way closer to 2. When I plug in 2.1, I think you get, what do you get? I think it's 4.1, right? Then you get 4.01, 4.001, and that's the idea. It's just the more, like, as you get closer and closer, you see here, this number over here is very, 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 very close to 2. And the closer and closer you get to 2, the closer and closer you get to 4. And that's it. So this is, notice that this is 4.1, 4.01, 4.001. And now here, for the magic, and I'm guessing some of you already did it because you're so fast, notice that for the graph, doesn't it look like a closed circle over here? And you think that f of 2 is 4, but when you plug in 2, notice that you get error, or it should be undefined, okay? And that is true. Here, the graph doesn't show it for Desmos, but if you actually take your mouse, and use the click arrow, if you click this here, you should get 2 comma undefined. And then you're going to notice that there's an open circle here. Even though the graph doesn't look like it, when you click over here at x equals 2, there's an open circle. And then now this is we have to think about this. You know, we have to think, why is this happening? And this question, what I'd like you to do is write it down. What is it algebraically for f of x equals x squared minus 4 over x minus 2? What is happening that when we plug in x equals 2, it becomes undefined? Why is it that when we plug in 2 in here, the equation doesn't give us a proper y value? Okay? Pause the video and think about it. And the idea is, when you plug in 2, what's happening to the denominator? Because if you have the denominator over here, this denominator over here, you have 2 minus 2, and notice that is 0. Remember, back in Algebra 2, we're not allowed to divide by 0. It's okay to have like 0 over 7 or something, right? You could have a 0 on the denominator, like 0 over 7 is 0. But if I had 7 divided by 0, this is undefined. And this is no bueno. You're not allowed to divide by 0. So that's the reason why over here it is undefined. Okie dokie. Okie dokie. So notice that. Notice from the left, it's going to 4, right? Which is this part here. Notice from the right, it's going to 4, which is this part here. So if you know from the left and from the right, it's going to 4, then the limit in general is 4. But at this point at 2, it is undefined, okay? That's why your eyes are misleading, okay? Your eyes might have thought this was it was at 4, but it's not, okay? Wow, that was 9 minutes and 20 seconds. All right, now let's try and do the next part over here. So let's take a look over here. Let me fix the camera angle. Okay. So now for this part over here, for the second page, it says, now let's say we have no graph, and we wanted to calculate the limit of a function that is approaching a certain x value. So if we have this function of x minus 3 over x squared plus 2x minus 15, what we want to do is, hey, what is it approaching? How is it approaching from the left, from the right? If the left and the right are equal, then this limit must be equal. Is it defined at f of 3? And notice that there's no graph. So how do you actually do this? Or how would I like you to actually do this example without me being there, right? What I want you to do is you go to desmos.com and I want you to erase everything from the previous example, and I want you to plug in the function f of x equals x minus 3 over x squared minus, this should be plus 2x minus 15. And now notice that, you see, if you plug this in, please don't plug it in yet. You're gonna get a picture, right? You're gonna get a graph. What I want you to do is just to use the calculator and do not look at the graph. But how are you not gonna look at this graph? What I want you to do is literally find something at home and cover your screen. Cover your screen so you do not see the graph. All I want you to do is look at what the y values will be when you plug in the values close to 3. I want you to cover this part of your screen so you do not